The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. Okay. So today we're going to be reviewing for the final again. We're going to be looking at material from chapter 8 first. We'll take a break after that and then go on to chapter 9. So let's go ahead and get started. But before I do any of you have any questions, any specific things you'd like to look at? If not, I'm just going to go through sort of the chapter reviews from the past. And if questions arise, please feel free to comment. Okay, well, we'll just get started then. Can somebody at least tell me this? Can you see the WebAssign screen as well as the whiteboard screen? Just want to make sure I've got the right stuff up there. Anybody?
Yes.
Okay, thank you. I knew someone was there. All right, thanks so much. Here we go. Come on, I move over there. All right, so problem number 1 says, let f of x equal 9x plus 8 and g of a equal a squared minus 4a plus 4 all over 9. Find the function value. Well, it asks you to find g of 8. So basically, f of x equals 9x plus 8 is interesting. It may be true, but it's not what we're going to use in this problem. We're going to use the one that says g of a equals a squared minus 4a plus 4 all over 9. All right. So g of 8, we're going to put 8 in the place of a everywhere it appears in the function. So we're going to get 8 squared minus 4 times 8 plus 4 all over 9, which is 64 minus, 64, it looks like 6 to the 4th power there. Sorry about that. Okay. 64 minus 32 plus 4, which is what? 32 plus 4 or 36, but that's all over 9. So g of 8 equals just plain old 4. Again, we don't do anything with the f of x equals 9x plus 8. If it asks us to find f of 8 or f of something, then we use that. All right. Any questions there? Let's take a look at another one. Find h of 2 and h of negative 2. If an answer is undefined, enter undefined. So our function is h of x equals 3 over the quantity x minus 4. So h of 2 would be 3 over 2 minus 4, which is 3 over negative 2 or negative 3 halves. Again, we move the negative sign either to the numerator or out in front, but we don't leave it in the denominator. All right. H of negative 2 is 3 over negative 2 minus 4, which is 3 over negative 6 or negative 1 half. Again, we can put the negative sign on top or out front. So h of 2 is negative. And then I need, let's see here. I guess I don't need the, well, yeah, let's see here. Negative 3 halves. Okay. And then this is going to be negative 1 half. Any questions there? All right, let's take a look at problem number 3, which is graphing. So we've got the function s of x equals negative 4/5 x plus 1. Now, there's two different ways we can graph this. We can recognize that it's already in slope-intercept form, So the slope would be -4/5, and the y-intercept would be 1. Graphing it that way, we click on this till it turns blue. We have a y-intercept of 1, okay? Then going down 1, 2, 3, 4, and over 1, 2, 3, 4, 5. And there we have the correct answer. Now, there's another way we can do this problem, and that is, instead of using slope-intercept form, take it and rewrite it as y equals -4/5 x plus 1, and find a couple of ordered pairs. Let's see. How about, let's let x be 0. When x is 0, we have y equals -4/5 times 0 plus 1, so y equals 1, okay? And then, how about if we let x equal 5? That'll work out nicely here. Y equals -4/5 times 5 plus 1. The 5's reduced down, -4 plus 1, -3. So then we have 5, -3. And I actually plotted the same 2 points, but you could do it either way, using slope-intercept form or ordered pairs. Any questions about that particular example? Okay. I'm just going to keep going right on down the line here. If you have some more questions, if you have something you want to look at in more detail that I do here or anything else, let me know. Happy to oblige. Write an equation for a linear function whose graph has the given characteristics. The slope is 1/4. And it passes through the point 8, 1. Okay, so I'm going to use the form y equals mx plus b. The slope is 1/4, so y equals 1/4 x plus b. What I need now is the y-intercept. I can take this ordered pair and put the 8 in for x and the 1 in for y, and get 1 equals 1/4 times 8 plus b. 1 equals, that's going to reduce down to 2 plus b. Subtract 2 from both sides, and b equals -1. So y equals 1/4 x minus 1. So that would be the same thing as in function notation, f of x equals 1/4 x minus 1. So right here we've got, let's see here, we're going to use that and 1/4. Now I need to use the right arrow key to get out from under the fraction, and then x minus 1. Double check my answer, make sure it's what I want to put in there, and there we go. Any questions about that? Okay. Number 5, write an equation for a linear function whose graph has the given characteristics. So it contains the point -2, 2 and 2, -12. Well, again, I'm going to use y equals mx plus b. I need to find the slope given 2 ordered pairs, calling this point 1 and this point 2. The slope is going to be y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So let's see, y sub 2 is -12, y sub 1 is 2. X sub 2 is 2, x sub 1 is -2. -12 minus 2 is -14. 2 minus -2 is 2 plus 2 is 4, which reduces down to -7/2. So that's going to go in here. Okay. Now I'm at the same place I was in the previous problem. I can use either ordered pair. I'll use this one, plug this in for x and this in for y. 2 equals -7/2 times -2 plus b. 2 equals, let's see, that's going to reduce to -1. -1 times -7 is 7. Subtract 7, b equals -5. So y equals -7 halves x minus 5, or f of x equals -7 halves x minus 5. If I'm going too quickly, please let me know. I'll slow down. So what do we have here? We have, let's see, -7 halves x minus 5. And again, I could have also written it as -7 halves x minus 5. I can put the negative sign in the numerator or out front. Let's see here. That's correct. And it is. All right. Well, if there's no questions, we'll just continue on. Write an equation for a linear function whose graph has the given characteristics. Passes through 4, 0, and is parallel to the graph of g of x equals -3/4 x minus 9. All right, parallel lines have the same slope. The slope of g of x is -3/4. So the slope of what we're trying to find over here is also -3/4. So we've got the slope and a point. So y equals mx plus b, the slope, y equals -3/4 x plus b. Okay, I'm going to use this ordered pair. 4 goes in for x, 0 goes in for y. We get that. The 4 is reduced down. We add 3 to both sides, and we get b equals 3. So y equals -3/4 x plus 3, or f of x equals -3/4 x plus 3. So -3/4 x plus 3. Okay, and I should point out, again, to check this, well, these lines are parallel. They have the same slope. If x is 4 and y is 0, so f of 4, -3 plus 3, 0. It checks. Okay. All right. Write an equation for a linear function whose graph has the given characteristics. Passes through 8, 0, and is perpendicular to g of x equals 2x plus 5. All right. Parallel lines have the same slope, but lines that are perpendicular, the slopes are negative reciprocals or opposite reciprocals. Well, the slope of g of x is 2. So the slope of the line that's perpendicular is going to be -1/2. Okay, so these have to be negative reciprocals of each other because the lines are perpendicular. So now I've got a slope and a point. Y equals mx plus b. -1/2 goes in for m. Y equals -1/2 x plus b. 8 goes in for x. 0 goes in for y. 0 equals -1/2 times x plus b, or times 8, excuse me. 0 equals -4 plus b. Add 4 to both sides. B equals 4. Y equals -1/2 x plus 4. F of x equals -1/2 x plus 4. Negative. Oops, that's not what I wanted. My bad. That's what I wanted. 1/2 x plus 4. Okay, again, be sure that what you enter is what you want to enter before you click submit answer. I get a lot of people after a test saying, oh, Mr. Mayo, I put in the wrong notation. Well, check it before you click it, okay? All right. Okay. Write an equation for a linear function whose graph has the given characteristics. It's horizontal, passes through the point 9, negative 41. All right. Horizontal. Well, the equation of a horizontal line would have to be y equals a constant, or y equals a number. Well, since it passes through the point 9, negative 41, the y value is negative 141. So f of x equals negative 41. I think I said negative 141. Negative 41. Okay. So negative 41. All right. In a proposal to some prospective clients, a housing contractor listed the following cost. Fees, permits, miscellaneous, $16,000. Construction per square foot, $55. Write a linear function that the clients could use to determine the cost of building a home having F square feet. All right. So the fees, permits, and miscellaneous, that $16,000 is what's called the fixed cost. That's a one-time cost. The $55 per square foot, that's a variable cost. That depends on the number of square feet in the house. So what we get is C of F equals 55F plus 16,000, because F is the number of feet, okay? Now, another mistake that students made on this kind of problem back when we took the Chapter 8 test is not paying close attention to the variables. This is F, and it's a lowercase f. So this needs to be 55F, okay, plus 16,000. If you put 55X there, it's going to mark it wrong, okay? Find the cost to build a home having 1,450 square feet. So C of 1,450 is 55 times 1,450 plus 16,000. All right, calculator time. 55 times 1,450 plus 16,000 is 95750. So let's see here. 95,750. Alrighty. Going on to the next one. Refer to the given graph to find each value. F of -1. So we need to look at the graph. The input is -1. So the input is -1. When the input is -1, what's the output? It's -2. Corresponding to the coordinates of that point right there. When the input is -1, the output is -2. F of 0. When the input is 0, the output is also 0. Okay. So given x, find y. This says given y, find x. The value of x for which f of x or y is 4. Y equals 4 is right there when x is 2. And y is -2 when x is -1. If you look at, let's see here, part A and part D, they're actually the same ordered pair. In part A, they give you the input, you find the output. In part D, they give you the output, you find the input. Okay. All right. Number 11, find the domain and range of the function. All right, the thing we need to assume, when the graph goes to the edge of the given grid, it's as if though there were arrows on the ends here. I wish they'd put them there, but they don't. So this graph continues on down. As it goes down, it goes to the left. This one goes down, it goes down to the right. So as this continues on down forever, it's going to go to the left forever and to the right forever. So the domain is going to be the set of all real numbers. Okay. But the range, this goes down forever. So it's going to be from negative infinity up to this value right here. Well, according to our scale, that y value is -1. So it'd be the set of real numbers less than or equal to -1. And again, I notice we've got some new people that joined us. If you have any questions about anything I'm doing, please interrupt, let me know. If you want to look at more examples of something, let me know. Otherwise, I'm just going to continue on. Okay. Find the domain and range of the function. Well, the domain is the x values. It starts at 0 and goes on to positive infinity. It looks like it includes 0. The set of all real numbers less than, no, numbers greater than or equal to 0. Yeah. Okay. Now, the range, the highest range value is 0. As this thing goes to the right, it goes down. So it'd be negative infinity up to and including 0, less than or equal to 0. Okay, any questions about that one? All right. Consider the following graph. Determine whether the graph is a graph of a function. Does it pass the vertical line test? Yes, it does. For each input, there's just one output. So yes, this is the graph of a function. Yes, this is the graph of a function. If we had a picture, well, here's an example, okay? This one is not a function. It fails the vertical line test. It says, if it is not, find two ordered pairs where more than one value of y corresponds to a single value of x. Well, let's see here. When x is -2, y is 1, and y is -1. But that's not on there. Let's see. Maybe what we need to do is, let's see, where x is -3, y is, no, that's not, when x is -2, that doesn't work. When x is -1, when x is 0, y is 3 and y is -3. So what you need to do is you need to check each set of ordered pairs to find out which one of these is actually ordered pairs on the equation that violates the vertical line test. Okay. Don't just say, oh, well, here's one, but those aren't listed there. Find one that is listed there. Okay. Find the solution set of the compound inequality. So we have 5 halves x plus 1/4 less than 7 and 4x plus 3 greater than 19. So this is an and situation. Is that an intersection or a union? That's an intersection. So first of all, we need to solve each inequality for x on the left. This first inequality, I'm going to clear the fractions by multiplying both sides by the least common denominator of the 2 and the 4, which is 4. I get 20/2, which is 10x, plus 4 times 1/4, which is 1, less than 28. Okay. Now, subtract 1 from both sides. 10x less than 27. Okay. Divide both sides by 10. X is less than 27/10. Let's see. Let me double check that. That should be 10, 1, 28. Got everything copied correctly. Over here, the second inequality, we're going to get 4x less than 16 divided by 4x is greater than 4. Okay, now let's graph each one of these. X less than 27/10. Let's see here. 27/10 would be 2.7, wouldn't it? So 1, 2, 3, 4, 2.7. So it'd be right about there. Okay. And then x greater than 4 would be there. Okay. So where do these intersect? They don't intersect, so there's no solution. Okay. Next problem, 16. Solve the double inequality, graph the solution set, and write it using interval notation. Okay, so we've got 0.3 less than 2x minus 0.5 less than 3.5. I've got a bunch of decimals I want to get rid of, so I'm going to multiply each piece by 10. 10 times 0.3 is 3. 10 times 2x is 20x. 10 times negative 0.5 is minus 5. And 10 times 3.5 is 35. Okay. And then we're going to add 5 to each piece. So 8 less than 20x less than 40. Remember, whatever we do to the middle, we do to each end as well. Now I'm going to divide by 20. So this is what? 4/10, 2/5, x and 2. All right. Now I'm looking at the graph and I see that it's got decimals. 2/5 would be what? 0.4. In fact, I cleared the decimals at the beginning. I could have left it alone, left it as decimals. Maybe if I paid more attention to the graph, I would have done that. All right, so, okay, we need the graph to look like this. Let's see, 0, 1, 2. We're going to have parentheses at 2 and parentheses at 0.4 and a solid going in between. So parentheses at 0.4, okay, and then parentheses at 2. Now, how do I get that line in between? Let's see what happens here. There we go. All right. Does that look right? Write the solution, interval notation. It would look like this. So now I need parentheses. Where am I going to get those? Let's see. Symbols? No. Functions? No. Relations? No. Sets? Ah, here we go. Sets. And I've got that. So I'm going to put in 0.4, comma, space, 2. And how do I get the right side? Let's see. I guess I can just use the comma. I don't know if that's going to show up or not. We'll find out. Yep. Okay. Any questions there? Well, we'll just continue on then. Solve the compound inequality, graph the solution set if one exists, and write it using interval notation. Okay. 7 less than 3x minus 2 less than 25. So I want to solve for x in the middle. I'm going to add 2 to all 3 pieces, giving me that. Divide by 3, all 3 pieces, giving me that. Okay, so interval notation would look like that, and the graph, let's see here, would look like that. So it looks like this one is the correct choice. Okay. Going on. Solve the compound inequality. Write the solution set if one exists in interval notation. 3x less than -6, or, excuse me, I wrote and, or it started to, or x over 2 greater than 4. So the first one, I'm going to divide both sides by 3 and get that. The second one, I'm going to multiply both sides by 2 and get that. Recall, we haven't done this, but if we do, if we multiply or divide both sides of an inequality by a negative number, that's when we change the direction of the inequality sign, okay? That hasn't happened yet, but it might. All right, solve the compound inequality. So we have, let's see here. Let's graph this thing, see if that helps. X less than -2 would look like that. X greater than 8 would look like that. So my point is, I've got two different intervals that don't overlap, but I want the union. So I've got -∞ to -2 in union with 8 to +∞. Okay. So that looks like, let's see here, this one. Okay. Now, what's the graph going to look like? It's going to look like a combination of these two. So I'm going to have that along with that. Okay, so I'm going to have a right parentheses at -2. And let's see, how do I get an arrow going to the left? There we go, arrow to the left. Okay. And then left parentheses at 8 with an arrow going to the right. Okay. So that's kind of like Hawaii, the union of two islands, actually more than two, but it's geographically separated, but the union includes all of it. Okay. Remember that? All right, let's keep going here. Solve the compound inequality. Write the solution set if one exists in interval notation. So 5.5 x minus 5 less than -16, or 5 minus 5x greater than or equal to 30. The reason I hesitated there is, remember before I had a problem with decimals and I got rid of them? So I stopped to look and see that I noticed that on my graph, the scale is not in decimals. Okay. Well, let's see. Let's take this first inequality. I'm going to add 5. So I get 5.5x less than negative what? 11. Okay. I could clear the decimals, but I'm just going to go ahead and divide both sides by 5.5. So I get x, and then let's see here. So -11 divided by 5.5 comes out to be -2. And over here, I'm going to subtract 5. So -5x greater than or equal to 25. I'm going to divide both sides by -5. Aha, so I changed the direction of the inequality there. So this is what I'm going to consider. Okay. Now, x less than -2, let's see, 0, 1, 2, would look like that, okay? X less than or equal to -5. Let's see. Less than or equal to would look like that. But I want the union of the two. Well, if this starts slightly before -2 and goes to -infinity, this includes all of this, doesn't it? So the union would look like that. Okay. Which would also look like that in interval notation. So I've got, let's see. Oh, what did I do? I forgot my negative sign here. It's a good thing that that wasn't one of the possible answers, having a +2. So that, and then graphically, I need a parentheses at -2 going to the left. Okay. Let's see here. Any questions about that one? Okay. Let's see, how many have we got left here? We've got a bunch of them. That's all right. We'll get through them all. Okay. Number 20 coming up. Solve the compound inequality. Graph the solution set if one exists and write it using interval notation. 2.2x less than -15.4 and -2x less than 16. So the first one, I'm going to divide both sides by 2.2. So x is less than, let's see, -15.4 divided by 2.2 is -7. And this was going to be x and then -8, but we're going to change the direction of the inequality sign because we divided by a negative number, okay? So x less than -7 looks like that. X greater than -8 looks like that. So the intersection would be that, and interval notation would look like that. Okay. So it looks to me like it's this one right here. All right, moving on. Absolute value. 2 times the quantity times the absolute value, 4x plus 1 minus 1 equals 19. Solve the absolute value equation. Enter your answers as a comma-separated list. If an answer does not exist, enter capital D in E. All right, so solving an equation with one absolute value, the rule is isolate the absolute value first of all. So I'm going to add 1 to both sides, which is going to give us that. I'm going to divide both sides by 2, which is going to give us that. Now that I've got the absolute value term isolated, I'm going to have 4x plus 1 equals 10, or 4x plus 1 equals the opposite of 10. Solving the first equation, I'll subtract 1. 4x equals 9, divide by 4, x equals 9/4. Solving the second equation, subtract 1. 4x equals -11, divide by 4, x equals -11/4. All right, now, how are we going to check our work on that? Well, let's take this one, 9/4, and put it in. Four times 9/4 is 9. 9 plus 1 is 10. The absolute value of 10 is 10. So we get 20 minus 1, 19 equals 19. So that one checks. Let's see, 9/4. It didn't say anything about putting the smaller one first. Now, again, I've got to move outside of it to put the comma in. I don't want to, if I put the comma down by the 4, it's going to be wrong. Space. Let's try negative 11 fourths. 2 times absolute value 4 times negative 11 fourths plus 1 minus 1 equals 19. The 4's reduce. Negative 11 plus 1 is negative 10. The absolute value of negative 10 is 10. 20 minus 1, 19 equals 19. So that one checks as well. Okay. So I've got negative, let's see, 11 fourths. All right. Next one, solve the absolute value equation. Enter your answers as a comma separated list. If an answer does not exist, write D, N, E. Well, an absolute value can't equal a negative number, can it? So there's no solution. D and E, here we go. D, N, E. I could have gone to all the trouble to solve it and gotten 2 answers and plugged them back in and seen that they didn't work, but yeah. All right. Solve the absolute value equation. And we've got 6 times the quantity 1 minus x plus 1 all over 6 equals the absolute value of 7x minus 2 all over 7. What I'm going to do, I'm going to simplify inside the left absolute value, but recall that when you have 2 absolute values, you want them separated like they are. All right, so what do I have over here? I've got 6 minus 6x plus 1 all over 6, which is actually negative 6x plus 7 all over 6. Combining like terms. Okay, so I can do that much simplification before I do anything else. All right, I'm going to take this and recopy it on the next page, so I have lots of room to work with. Negative 6x plus 7 over 6. Let's see, did I get that right? And then 7x minus 2 over 7. 7x minus 2 over 7. Okay, so my 2 possibilities are negative 6x plus 7 over 6 equals 7x minus 2 over 7, or, and that negative is just on top there, just in front of the negative 6, or negative 6x plus 7 over 6 equals the opposite of 7x minus 2 over 7. And notice I put the negative sign out in front, the opposite of the whole thing. Okay, the equation on the left, we're going to multiply both sides by 42. 42 over 6 is 7. So I've got 7 times negative 6x plus 7. And over here, this 42 and the 7 reduced down to 6 times 7x minus 2. So that gives me negative 42x plus 49 equals 42x minus 12. Okay. Subtract 42x from both sides. Negative 84x plus 49 equals negative 12. Subtract 49, negative 84x equals negative 59, 61. Divide both sides by negative 84. X equals 61 over 84. Okay. Second one, I've got, let's see, I'm going to multiply both sides by 42. So over here, I get 7 times negative 6x plus 7. And over here, I get 6 times, and then a negative outside. Okay. Oh, the 7's gone now. So it's negative times that. So I've got negative 42x plus 49. And over here, I've got negative 42x minus 12. If I add 42x to both sides, I get 49 equals negative 12, which doesn't work. So I've only got one solution. And I know I kind of went quickly there. I'm trying to get through all this. I should just slow down. Let's see what happened here. Here's hoping. All right. We've got a couple of variation problems, and we'll take a break and come back and take a look at chapter 9. The property tax in a certain country varies directly as assessed valuation. So we've got, we've got property tax, let's call that big T, and direct assessed valuation. Assessed valuation, let's call that V, okay? Property tax varies directly as assessed valuation. So T equals KV. Remember K, variation constant, not often not mentioned, but always present, okay? If a tax of $16.35 is charged on a single family home assessed at $93,000, so the tax $16.35 equals K times $93,000. Determine the property tax on an apartment complex assessed at $310,000. Okay, so the next thing we're going to do is divide both sides by $93,000 to solve for K. So K equals, the dollar signs will go, let's see here. Hopefully this will come out nicely. 1635 divided by 93,000. It doesn't come out nicely. So I could reduce that thing down, but you know what? I'm just going to leave it like this because it's not really asking me to get K as a final answer. I'm going to just be using K. All right, so this was 93,000, okay? And again, I could take out a 5 and reduce it down, but so now I've got this, T equals 1635 over 93,000 times V, okay? Now, determine the property tax when it's assessed at 310,000. So I've got 1635 over 93,000 times 310,000. Okay, so 1635 times 310,000 divided by 93,000 comes out to 5450. So 5450. And finally, let's see, for a fixed voltage, the current in electrical circuit varies inversely as the resistance. So we're going to let C, there we go. C is going to equal current. And R is going to be resistance. Okay, so for a fixed voltage, the current varies inversely as the resistance. Okay, if a certain circuit has a current of 3.5 amps, so 3.5, when the resistance is 140 ohms, okay? So we can solve for K by multiplying both sides by 140. I'm going to change 3.5 to 3.5 just to make it easier to put into the calculator. So I get 490 equals K. So this means C equals 490 divided by R. Okay, putting that in the place of K. Find the current in the circuit if the resistance is doubled. So instead of being 140, it's going to be 280. Okay, so 490 divided by 280 is 1.75 amps. So here we go, 1.75 amps. All right, we're going to get ready to take a quick break here. Before we do, are there any questions that you want to talk about? When we come back, we'll be doing chapter 9. Anything? Okay, so I'm going to stop the recording.